Can we start, sir?
Yes, Professor.
Okay, sir. Good afternoon, participants. Welcome to the last session of our 2 weeks AICT FDP on electric vehicles. So today, for the last session, we have our Mohamed Ibrahim, sir, Assistant Professor Senior Grade from Cape Air Institute of Engineering Technology, to handle the session on electric vehicle design. On behalf of the management and the organizing team, I welcome him for this session. Welcome you, sir.
Thank you.
To tell about Ibrahim sir. Ibrahim sir is working as an assistant professor in the Department of Electrical and Electronics Engineering at Cape Air Institute of Engineering Technology, Coimbatore, with an experience of 10 years. He received his BE degree in Electrical and Electronics Engineering from Sri Krishna College of Technology, Coimbatore, and ME in Power System in Engineering from Government College of Technology, Coimbatore, and is doing his PhD under Hana University, Chennai. His research interest includes optical power flow using packed devices and soft computing. He has published more than 25 research papers in various international journals and 30 papers in international conference and 10 papers in national conference. He also holds 2 patents in his credit, and he has also authored a book chapter in the field of electric vehicles. He has completed around 25 online courses in platforms like NBTEL and Coursera, and we are very much delighted to have him as our resource person for the last session. Sir, I request you to take over the session, sir.
Thank you, Ravi sir. Thank you. So, good afternoon to all present here for the wonderful 2 weeks AICT electric vehicle program. So, this is the last session regarding the electric vehicle design, which is a trending topic, and it is trending in the world, EV. So, we are facing the crisis towards an petroleum products, and we are moving towards the next technology, which is called as an electric vehicle. So many industries are focusing towards, that is two-wheeler and two-wheeler, three-wheeler, four-wheeler. All the industries are focusing towards the next technology, the electric vehicle design, and many opportunities are there, and the researches are going on towards an electric vehicle and design. So in my part, so I like to share a small concept regarding electric vehicle design using MATLAB software. So what we know was a conventional electric vehicle. So conventional vehicles was in terms of diesel or petrol. There's many mechanical parts for manufacturing an vehicle. So in an electric vehicle, so we are made of a chassis and accessories which along with an chassis was an battery and motors, and it has many converters are there. So when compared to conventional vehicle, either four-wheeler or two-wheeler or three-wheeler, so the electric vehicle has lesser number of parts, and the maintenance was comparatively easy when compared to the conventional vehicles. So in my team, the electric vehicle design, so what we are going to see is to see the how to make a simulated part. So how the researchers are doing, how we can able to given what is an input, that is an virtual results of an uh, vehicle. So that's my work that I like to share for next half an hour. So the thing which is shown in was in chassis, which has an tire along with an chassis. So this is an base of the vehicle. So this is a part which has a motor along with batteries. So this is entirely called as an electric power train. So this has an batteries, motors in a chassis along with a tire. So this is a major part in an electric vehicle part. So the objective was to make a more simple and low run time vehicle model using individual component model. So what I have planned was so what are the components that is mandatory or the necessary components for um, mm, to make a electric vehicle. So that is the thing that I like to share in MATLAB 2020A software. So next thing I like to share the performance parameters such as speed, state of charge, current with the various drive cycles. There are many number of drive cycles are there. Let's we see what is called drive cycles and etc. So next thing was then to play with motor power, vehicle body, rolling resistance, air drag, weight inputs. So we'll a little bit see about these topics and to know about the MATLAB models and the configurations to match with the actual vehicle. So these are the objectives that I like to uh, share in this session. Probably I like to complete as soon as possible. So let's we go to the session with an the objective. This is on a block diagram. So how will be the electric vehicle, the basic block diagram of the structure. So this is called as an vehicle body. So vehicle body consists of an that is called as a power train, which is an chassis along with a tire is a vehicle body. So in that, so we have a driving mechanism. So as this was an electric vehicle, so we are going to go with an electric motor. So what I have taken was a permanent magnet DC motor. So we can use an brushless DC motor, or we can go with an induction motor. So many researchers are going towards it. So next thing was then to control the motor. So we are in need of some converters. So what we have selected was an H bridge converter, which has an four power switches. So it can be used for four mode of operations. So as we have no forward, reverse, forward braking, reverse braking, regenerative braking. So these are the some of the four quarter operations that we can able to do in this H bridge converter. So as we have taken as a DC motor, so that we can able to drive the machine in forward direction as well as in reverse direction. Forward braking and reverse braking can be done. So we can take as our interest. So we can take in different types of motors as we are going to see the basics of how to design these things. So I have taken as an DC motor, permanent magnet DC motor. So next thing was then a power converter H bridge. So in H bridge converter, so we are going to drive. So this is called as a driver, and we are need of a controller for the driver. So we have taken as an PWM as an driver in H bridge. So next thing was an drive cycle. So as I have said before itself, the drive cycle. So we have a different drive cycles or the longitudinal drive cycle has been taken in this structure. So we can see. So what is it? What it does? So next thing was in battery charge, discharge, and the state of charge conditions can be monitored because it is an electric vehicle. So the power is taken from the battery, and the battery power is charging, discharging, and state of charge should be regularly monitored and maintained based upon the load as well as speed how we are taking during the running condition. So this one is a simple block diagram. So according to this block diagram, so we'll see the MATLAB model. So what I have taken was a 2020A MATLAB version. So what we have to consider was, and so as of block diagram is concerned, so vehicle body is an we have to coming from the back to front. So that is our work. So first we have to take the tires. So as we are focusing towards on a four wheeler, so we have to take on four tires for constructing the Simlink model. So there are different types of models will be open. So what I have taken was a tire magic formula. So as it was in a basic, and we are considering this as a model. So as it was on four wheeler, so we have to take some four wheels. So next we have to select the chassis, which is called as an vehicle body. So the block parameters of tire, there are various instructions and various things are there. So tire magic formula. So the various parameters are there that we have to consider while designing a system. So rated vertical load, so how far the load is going to take, and peak longitudinal force at rated load, and slip at peak force. So next thing, there was a geometry is there, a dynamics is there, a rolling resistance is there. So we have to on and off, and velocity threshold is there. So these are the various things that we are keeping as a default, and we are going to work. So So we have to consider this as an these two wheels as an rear wheel, and these two wheels as an a front wheel. So A is called as an axle and H is called as an hub. So vehicle body. So in the vehicle body, so we have various parameters that we have to consider. That is mass. So mass is an total mass, that is an hub weight as well as including the passenger and driver's weight we have to consider. So that is called as a mass. Next thing was the number of wheels per axle. So we have four wheels per axle. So we are going within two wheels. So horizontal distance from near axle. So these are the things that we are going to keep it as uh, the existing thing. And this is drag and pitch and variables. These are some of the mechanical terms that we are need to know. So there are data sheets are available. So we have to take the certain things for making electric vehicle design through simulation software that is using MATLAB. So So what I'm showing was then this is a vehicle dynamics. That is, then we have on four wheels, and these two wheels are connected as an rear wheel, and these two wheels as an connected as an a front wheel. So we have to connect the axle of the two wheels of rear and the axles of the front wheel, and we have to connect the hub of all over the four wheels, and it has to be connected to the powertrain. So that is an vehicle body. So before that, kindly make it as a tilt by right click your the icon. So you'll get a few instructions that you have, or you go with an Control I to flip the content. So I have changed through Control I. It is easy to connect For that purpose only we are making this thing. So vehicle body has an or 6 terminals will be there. So in that NR is called as an rear wheel, and NF is called as a front wheel, and delta is called as an how the angle the vehicle is traveling. For example, if it is going towards an hilly region, so there is a change of angle will be there. So for that, so what will be the changes in output will be monitored. And V is called as an velocity. V is called as in vehicle velocity, and W is called as in wind velocity. So these are the things. Then H is called as a hub, that we have to connect all those. We have to connect these 4 wheel to the vehicle body. So that is happen due to the hub that we are going to connect through the hub. So and we have to connect the axle of the front wheel. So these are the input parameters that we have to give. So I'm taking it as an port, and we can make this as a subsystem. So how we have to make subsystem means, by selecting all those components and by right clicking, so you can have an thing is called as an subsystem. So this is called as an vehicle. So vehicle has an vehicle body as well as 4 tires. So when we click, so we can see this is generally called as a vehicle. So this is a thing that is called as a chassis. Chassis which has an the vehicle body and then tires. So this is an general simulation model that we can able to do in MATLAB simulation software. This is a main thing that we have shown in a block diagram. Our block diagram. So what we have designed was a vehicle body. So it has a drive cycle, driver controller, power converter, permanent magnet, DC motor, vehicle body, and battery. So these are the things. These are the 6 blocks that we are going to design. So out of which what we have designed was a vehicle body. In vehicle body, so chassis is designed. The chassis along with an tire. So using MATLAB software. So I think it was clear. Kindly go through it if you have any doubt in it. So number of videos are there. You can kindly see those videos and you can learn it also. YouTube channel videos are there. So next thing what we are going to design was a DC motor, a permanent magnet DC motor control that we are plan to, that we have to connect to the powertrain, that is electric powertrain. So that is a permanent magnet DC motor control. There are different types of DC motors are there. So what we are taking was in a brush DC motor, that is permanent magnet DC motor. So there are brushless DC motors are there, and we can use an either induction motor also for the for the research purpose. So what I am going to take was a permanent magnet DC motor, which is a base, and we can easily can get a result towards it. So it has two colors. One is in a blue and another one is in green in color. So the blue color is called as an electrical part, and whether the green color is called as a mechanical part. So we have to give the supply to the electrical part, that is blue colored, and the green is called as a rotor, which is a rotating part. So the rotating part we have to give to the wheel. So that is a tire. We have to connect to the tire, and C is called as an so it has some vibrations will be there. So in order to control the vibration, so we have to go with a mechanical rotational reference, which is an act as a casing. That is, it should not rotate. Whether the rotor has to rotate in the motor, whether motor should not rotate. So for that, we are keeping casing. C is called as an casing. So we have to make an to fit it into the vehicle body. So that is our agenda. So in that, C is called as a casing of motor, which we have to connect through the mechanical rotational reference. So for that is for the mechanical stability of the motor. So there are different blocks are there that we can able to take, and we can make it. So mechanical rotational reference. So what we have to do is that is in a motor. So this rotor has to be connected through the simple gear. There are different types of gears are there. So the purpose of gear is to make an number of rotations to be increased in a machine when compared to the speed of the machine. Because maximum, for example, if we are considering the speed of the motor was 1500 rpm, so our speed has to be increased to 3000 rpm. So in that case, so we have to go for an gear system. So there are different types of gears are there, and what we are taking is called as a simple gear system, and we have to connect the rotor of the motor to the gear, and we have to connect this F to the inner part of the tires. So we'll do. So I have made an block. So I'll show you. So this is what I have model was a motor control. So this is a general motor control of a system. So what we have shown in the block 2, that is permanent magnet control. So we have to integrate to the vehicle body through the simple gear system. So what we have made, the first was an vehicle body along with an tires. So we have taken 4 tires along with the vehicle body and we have integrated. And we have made this as a vehicle. And next thing was then to drive the tires or drive the vehicle. So we are in need of an electric motor. So this is a setup which is called as a permanent. What I have taken was a permanent magnet DC motor. So in that permanent magnet DC motor, we have as an two parts. One is called as in blue in color. Another part is called as an R, which is a mechanical part, and this is called as an electrical part. And mechanical part, so there is a rotor, and we are giving the rotor output to the input of the simple gear system. So from this, we are integrating this gear system to an wheel or tire of a system. So we have to give an input to the motor. So this is a part which is called as a DC motor system. I think it was clear. So next thing what we are going to see was an H bridge, the regenerative braking system. So this is an H bridge system which has an PWM as an input. So what I have said was an driver control. So we are controlling through the PWM signal. So this is an H bridge which has an 4 inputs. So just take this as and click the block parameters. So by in power supply, so go with an external and give them apply and OK. So we have an so when we enlarge it, so we can see we have on 4 switches. So this is for an 4 quadrant operation. What I have said for an reverse forward direction, reverse braking, and then forward braking. So we can able to make by this H bridge control method. So it has an 2 terminals, that is an positive voltage negative, and this is an positive and negative. These two for an input of the motor, and these two is for an output of the converter. So what I will do was then, so we'll give an input to the DC motor. So this is why this is how the things will be there, and this is an PWM signal that we have to give the PWM signal, and there is a generator, PWM generator is there. So we have to give the signal to the PWM. This is a reference, and this is for an reverse, and this is for an braking, and this is a reference, and this is an reverse, and this was an braking. So in the parameters of an DC motor, so there are similarly permanent magnet or wound rotor motor. So that is in field type. Either we can take it as a permanent magnet or wound type. Some of the parameters are there that we have to go with an things with an existing one. So on the rotor inertia, rotor damping, and these are the parameters where we can able to take from the data sheets. So this is for your reference. I'm saying so everything is available. Kindly go to refer a few things that it has on a YouTube channel. So for our convenience, so this is to show that how the H bridge has the four switches. So for our convenience, we are converting it as into an internal itself, and it has an enabled threshold voltage PWM single amplitude reverse threshold voltage. So this is for an reverse purpose, and this is for an braking purpose. So we are giving a 2.5 volt as an input to the PWM through PWM signal. We are giving as an for braking the threshold voltage will be 2.5, and for reverse purpose we are giving 2.5 volts. So for enabling the threshold voltage 2.5 volts, and the PWM single amplitude is 5 volts, and the output voltage magnitude was 12 volts, as we have a battery capacity of 12 volts. Total bridge resistance is to a 0.1 ohm, and freewheeling diode on resistance is 0.05 ohm. So keep this as an existing one, and for our easier purpose we have converted the term as internal to external things. Just connect the terminal positive to positive and negative to terminal to negative. So before that, due to internal connections of the H bridge converter, we have four terminals. So it becomes complicated. So I have changed it to external, and it has become two terminals, positive and negative, and which is directly connected to the DC motor. So this is an design of power converter H bridge with a regenerative braking condition, that it has an reference forward reverse braking conditions through PWM signal. So what we have shown was an vehicle body, so permanent magnet DC motor. So next thing was an power converter H bridge. So next what we are going to see was an driver controller. So the controller what we are taking was to give an input to the PWM. So what we have to select was an control PWM voltage. So there was a block is there. So connect this PWM to PWM. So this reference to reference, and we have to take an electrical reference. There is a block called electrical reference. So these are the things that we have to work to get the answers. Connecting right. negative reference and reverse. So these have to be connected to an electrical reference. So the block parameters. So few things are there. So PWM frequency, pulse, delay time, pulse with offset. So minimum pulse with simulation mode. So we have an simulation mode of PWM and average. So we'll keep with an average the things. It becomes an easier for us. So input scaling, the output voltage. So these are the things that we have to give an proper input to get a proper output. So for this reference, so we have to give an AC electrical voltage source. So in MATLAB, it has some different things are there. So while going with a controlled voltage source, it is in black in color. We can't able to connect this thing in this because there is EV has some certain things which has to be taken in the color what they have what it is going with was in blue in color. So and we have to consider and we have to take the another one. Control voltage source in blue color has to become then only it has to be connected. Controlled voltage source. I think second one it has no. So while you can see this, so this is in blue in color and it can be connected. Yes. So this is a block of an driver controller. So what we have shown was an vehicle dynamics. So this is a vehicle body along with a four wheel. So where A is called an axle and this is an rear wheel and this is a front wheel and we can and we are connecting the hub which is in a hub and these two whole hub is connected to the vehicle body. So what we have done was then we have converted this in subsystem and this is generally called as a vehicle offices vehicle that it has an vehicle body that is chassis along with a tire. So next thing what we have shown was then this is a simple gear system that motor and the tire of the vehicle it has to be connected through the simple gear system. So this is a second block. What we have shown was a DC motor that is a permanent magnet DC motor. We can take a brushless DC motor or induction motor. So the taken was in permanent magnet DC motor. So in this there are electrical part and this is a mechanical part. This is a rotor. That rotor is connected to the input of the simple gear system, and the simple gear will be connected to the vehicle body. I have another diagram. I will show you the final output. What I am showing to you all was in a separate block. So next thing was then a PWM generator. So we have an H bridge converter is used. So why we are going with an H bridge converter means it has an four switches. So for four quadrant operation, so it is easier for making the vehicle to forward direction as well as reverse braking and forward braking, and we can able to make as an regenerative braking also can be done. So next thing was then the block is called as an driver controller. So the driver controller is used to control the driver, that is H bridge, through the PWM signal. So we have a block is called as an controlled PWM voltage. So in this the PWM is connected to the PWM and reference is connected to the reference. So this is on reverse and this is on braking, and we are connected everything to an electrical reference. So for this reference, so we are giving an voltage is called as a controlled voltage source. So we have to see that different sources are available in the MATLAB for different purposes, and we have to consider the current source that is a correct source for our purposes. Okay. So what we have shown was an four blocks we have completed, and we have to see the final block is called as a drive cycle, and we have a different drive cycles are there. So this is called as a longitudinal driver. So what we can able to see was an so acceleration, deacceleration. This is generally information. So this is an reference. This is an velocity. So this is a velocity reference. So this is an velocity, and this is a grade. So we can given this grade as a constant value. Some constant values can be provided. So in the system, what we have going to do was then so the instructions what we are planned is controlled by means of a longitudinal driver. So the informations are passed through the system. So how we are controlling was then so already we have no so the controller type what we are using was then proportional integral P controller, PI controller, or the differentiator, PID controller can be used. So in the system, so what we are using was an PI controller. So this is called as a longitudinal driver. As the time is going, so I can show the things what I have done earlier itself. So this is called as an longitudinal driver. And what are the things that we have been integrated with this longitudinal driver was, so this is called as a drive cycle source. Uh, so what it means, so for example, if two members are traveling in a car, so for example, so I'm a driver and along with me there is a friend means, so this is called as a friend, and this is myself, which is called as a driver. So the friend instructs the thing, so how to drive the car to the driver. So owner can give an information to the driver. So this longitudinal driver is called as a driver, and this is called as a owner of a car, and he instructs so how far and how the vehicle has to be driven. So what the instructions from this version, this is called as a drive cycle source, which is available. So kindly see there are different sources are there in latest versions. So we can see number of resources. I can't able to see the resources in 2021A. So we can see number of drive cycle sources are there. We can select whatever may be the thing that we are interested. So next thing was in of tracking system. The fault tracking systems can also be identified in the can also be identified. So the this is giving as an input to the system. So this is called as a multi-port. What this multi-port gives, so I will say you. So this is called as a signal builder. So the purpose of signal builder is used to control the speed of the, so the input can be controlled by means of a signal builder. So as we are seeing in live, so there was some due to network problems, so I can't able to show it immediately. The software 2020 has an huge processing time. So sorry for the inconvenience. So this is a signal builder. So this is a time scale, and this is an or speed can be adjusted. So how we can able to adjust means by just pulling this. So we can able to adjust the things, the axis, right axis, left axis point, and we can able to adjust the speed. So how far the time and the speed can be controlled, can be adjusted by this. This is a one method we can able to give as an input, and this is a spreadsheet. This is a spreadsheet that we can able to give the input data. So for our convenience, we can give an input data. So for that data only it operates. So this is called as a multi-port switch. So what we have taken was a three input multi-port, and what we have taken was a three input. Either we can get an input from the drive cycle source. That is, if we consider that the owner can command the system, that is, owner can command the longitudinal driver, or the system, the inbuilt system can be incorporated, that we can able to change the input. While this is a spreadsheet input, that fixed values can be given to the longitudinal driver. So how we can able to change, switch over this means, so this is in a command window that we are giving a constant. When we change this as to 2, the automatically it changes to a second input, and similarly it changes to the third, and similarly it goes. Okay, so this is what how we can give an input to the system by changing the inputs. So we can say the variable parameters. So for example, see the plot drive cycle, so how it was. This is how the for various time the speeds can be allocated, the velocity for different time seconds. I think you can able to visible those things. So everything is available. So based upon our work, we can able to take it out, or we can take an update simulation type. Once we run the system, so we can able to take the updated simulation time along with the velocity what it has been currently running in the system. So this is the drive cycle what we have shown. The vehicle body, which is controlled by the permanent magnet motor control. The permanent magnet motor control is controlled by power converter, that is in H bridge with the regenerative braking system. The H bridge is controlled by the driver controller, where driver controller is called as a PWM controller, where the PWM controller are controlled by the drive cycle. So the drive cycle what we have taken was the longitudinal drive cycle. The longitudinal drive cycle is controlled by either of three modes. So either by means of a drive cycle source, or by means of an input signal, that is a signal builder, or by means of a spreadsheet, what the decision for based upon the researches, so we can able to take. So by means of a multi-port input, so we can select any one of the input to the longitudinal driver. So from this longitudinal driver, the acceleration command, so this has an command which is called as an acceleration deacceleration command. From this commands, so we can able to accelerate our vehicle or deaccelerate our vehicle by this simulation. So we can able to find out so how far for the inputs our output will be there. That is how efficient our system is operating. So this is an video that final block as was to. So this is a graph which has in two lines which we can't able to see. One is in blue in color, another one is in yellow in color. So one is an input and another one is called as an output. So based upon the input, that is in a longitudinal driver, so how the input will be there, and the output is uh, evaluated. That is speed is monitored at the inside. That is an drive power drive. That is power wheel drive side. That is at the end of the tire. So we are measuring. So speed is measured. This is some of the output. So what we can, this is an entire block diagram. So what I have shown was an different references resources. So at final, so sorry to say that battery storage system. So there are different types of battery systems are there. I'll show you the system. So what we have taken was a conventional battery system. Uh, the actual battery which is used in a vehicle are also available in our it is a specialized power system batteries are available in MATLAB software, but it takes more time for simulation. So for that purpose only, I have say taken a simple battery of 12 volt for the system. So this is a battery which is used for real time simulation research for the electric vehicle. Uh, so the different types of batteries: lead acid battery, lithium ion battery, nickel cadmium, nickel metal hydride batteries. These are the things that actually utilized in the system for simulation purpose. Due to time constraints, we can't able to simulate the system. So for that purpose only, I have gone with a simple battery. A simple battery of nominal voltage of 12 volts has been taken. So which is connected to the controlled current source. So we have to given a controlled current source, and this output is connected to the DC motor. So you can see the DC motor is powered by PWM signal, as well as the battery voltage is connected to the DC motor. So this is what how the six blocks has been taken, and by integrating all those six blocks, so we can able to see the whole electric vehicle system. So drive cycle, driver, controller, power converter, for permanent magnet DC motor control, and vehicle body, and it has been controlled by the, that is H bridge converter is controlled by battery charge or discharge or state of charge conditions can be uh, controlled by the H bridge converter. So what I have shown was in a separate block. So by integrating all those things, so we can get an output of the system. Due to I have taken 2474 seconds, taking too much time for giving a certain output. So the output will be similarly like this. So this is a speed graph. the input and output can be taken. So in this, this different speeds are monitored in the system. You can make some research paper and you can try over it, and it has an many opportunities are there. As of EVs are going to be next booming. That is what the statistics says is next 2025 to 2100. That is 2100. So next booming sector is an electric vehicle sector. So that is in four wheelers and two wheelers. So researchers plays a vital role, and success rates also in many industries. The recent time the Ola has taken as an world largest two wheeler electric factory, even though the conventional legends are there. Due to the many research works, the progress is going on, and we are also, as KPR Institute, also working towards more towards an electric vehicle, and by support of Bosch, Robert Bosch Industry. So we are engaged in a center of excellence towards the research work in electric vehicle. And if you have dignitaries from other colleges can also visit our institute regarding EV discussions. So thank you all for the patient listening. So I have shown some basic ideas how we can take those blocks and how we can able to integrate. So kindly go with then a few examples that the MATLAB has, and if you are interested, you can go with then certain outputs. Definitely, it will be useful for the enriching the ideas of the students side. Thank you all for the patient listening. Thank you, Ravi Kumar sir. Thank you.
Thank you, Ibrahim sir. Thank you.
Ask the resource person.
Thank you, ma'am.
So if there are no more queries, I would like to thank our resource person for the session, Mohamed Ibrahim, for his wonderful hands-on training with MATLAB with the design of electrical vehicle. You have thoroughly summed up the entire FDP, sir. We have been seeing a lot of explanation, a lot of presentation. This was an hands-on session so that people will go with the filled heart so that they have taken a design process. We would like to thank you for that, sir. And on behalf of the entire team, organizing team, we would like to thank all the resource persons who have been there from day one of this FTP, and we would like to thank AICT also for believing in us and providing us funding continuously through our Atal sessions or through these type of FTPs and STTPs we have been conducting so far. We would like to thank all the participants, without which we will not be able to complete the series 1. And we will be back with series 2. Hope you will get the same amount of support from you for our series 2 also. At this juncture, I will thank the organizing, on behalf of the organizing team. Thank you so much for being there and helping us to complete the series 1 in a successful manner. The certificates will be sent to your mail within 1 week of time, and we will post the all the videos will be posted in our YouTube. You can check our channel, which is about EEE KPR IET. We'll share the link in the our WhatsApp group as well. Thank you all. Thank you once again.